May 1945. The hot New Mexico desert seemed far from the ravages of war in Europe. $100 tons of TNT, a rehearsal to scale and calibrate the power of an untested atomic weapon. Two months from this day, man would unleash the destructive power of a demon locked within the very fabric of matter and plunge the world into the atomic age. For the next 20 years, testing the power of the atomic bomb would hold the world captive by events shrouded in secrecy. Events set into motion 7 years earlier.
March 1938. Hitler invades Austria. The Third Reich begins to flex its military muscle. Later that year, German scientists discover fission of the uranium nucleus, bringing the Third Reich one step closer to discovering the secret of the atomic bomb. Fear of German research stimulated activity in the United States and England. Fear that German scientists could produce weapons of great devastation. In the fall of 1939, Dr. Albert Einstein wrote his now famous letter to President Roosevelt, explaining the urgency of work on uranium fission. Roosevelt, a man of action, moved swiftly. An advisory committee on uranium was appointed. German forces invade Poland, plunging the nations of Europe into a Second World War. A new branch of the Army's Corps of Engineers was established to administer work on military uses of uranium. Major General Leslie R. Groves, the man responsible for the Pentagon, was placed in charge of the project. On December 2nd, the first self-sustaining chain-reacting pile was successfully operated by Enrico Fermi. Fermi's success brought intense efforts between government and the private sector, creating huge industries for uranium separation in the town of Oak Ridge, Tennessee, and for the production of plutonium in Hanford, Washington, at the shores of the mighty Columbia River. This tremendous effort forged the materials necessary for creating an atomic bomb. The first atomic bomb was assembled at Los Alamos, a secret laboratory in New Mexico. When Dr. J.R. Oppenheimer arrived to take charge, he began to surround himself with a galaxy of outstanding scientific stars. From Los Alamos came the bomb design and treatment of many theoretical problems. Yet many questions still remain unanswered. What are the secrets of this new source of power and destruction? Knowledge and information on all aspects of this new weapon are essential and can only be discovered by further testing.
I had a very good friend, a Hungarian, 10 years older than I, Teocilat. He had a very independent mind and a great feeling what is coming. He saw years ahead that nuclear explosives would become important. He was a friend, and I helped him. For instance, I drove him to an important interview with Einstein, where Einstein wrote a famous letter to Roosevelt that started things going. I myself was interested in theoretical physics, in explaining atoms, molecular vibrations, knowledge, and more knowledge. I didn't want to do it. But then, Hitler not only swallowed up half of Poland, he invaded the West. And 2 days later, there was an invitation to a Pan-American Congress, where Roosevelt, whom I have never seen before, was going to speak. And he made a remarkable speech, how the world is really endangered by Hitler. Among other things, and at the climax, he said, you scientists are blamed for the weapons to be used. But I tell you that if you now won't work on weapons, the freedom of the world will be lost. Now, you know, I had the feeling that Roosevelt was talking to me. I was there when the letter was signed that awoke his interest in nuclear energy. I thought I knew he was talking about nuclear energy. Of the 2,000 scientists there, I felt he was talking to me. Of course, not true. But in that 20 minutes talk, my mind was made up. I continue to like better to work on pure science. But this had to be done. And as long as it had to be done, and I could contribute, I did, and was never sorry for having done it.
The uranium gun weapon, or little boy bomb, was a simple design, and scientists were confident it would work without testing. The Fat Man, or implosion bomb, was a more efficient design, using plutonium instead of uranium. Inside the very center of the bomb was an initiator, surrounded by a sphere of plutonium. This sphere was encased within a set of symmetrically located, high-explosive lenses, creating an implosion which forced the plutonium into itself, attaining critical mass. The blast instantly raised temperatures to 10 million degrees, releasing a force of 1 million pounds of pressure, vaporizing the tower and all desert life within a half a mile. The intensity of light was sufficient to cause temporary blindness to an observer 10 miles away. With a yield 200 times greater than the 100-ton test, the fireball created a crater nearly 1/2 mile across and fused the desert sand into a green glass still containing traces of radioactivity 50 years later.
Harbor plunged the United States into war. For 3 years, gathering momentum with each small victory, our forces had conducted an offensive against the war-bloated empire of the rising sun. Slowly, island by island, mile by mile, and then with ever-quickening sweeps, the combined land, sea, and air forces of the Allies drove against the borders of that empire, forcing it back until late in 1945, only the bastions of the Japanese home islands remained to be stormed. Ahead lay the greatest campaign of all, invasion of the Japanese homeland, and close-in, desperate fight. That this fanatical enemy would not quit until her last fighting man had been driven from his cave and killed had been established time and again by bitter experience.
The uranium gun weapon, or little boy bomb, was detonated over Hiroshima at an altitude of 1,800 feet, the height to achieve maximum blast effect. 3 days later, the Fat Man implosion bomb was detonated over Nagasaki. In Hiroshima, 70,000 people were killed or listed as missing. Of its 90,000 buildings, over 60,000 were demolished. The implosion bomb, dropped on Nagasaki, took the lives of 42,000 people and injured 40,000 more. It destroyed 39% of all the buildings in the city. With a yield of 20 kilotons, similar to that of Trinity, this weapon would be considered a nominal atomic bomb and provide a blueprint for all future nuclear weapons.
But the principal targets are naval ships. We are seeking primarily to learn what types of ships, tactical formations, and strategic dispositions of our own naval forces will best survive attack by atomic weapons should we ever have to face them.
Eleven months after the bombing of Hiroshima and Nagasaki, Operation Crossroads was conducted at Bikini Atoll, 2,500 miles west of Hawaii. The purpose of Crossroads was to test the effects of atomic weapons using two devices, similar in design to Trinity and Nagasaki, codenamed Able and Baker. Shot Able was to be dropped from a B-29, while Shot Baker would be detonated 90 feet below the surface of the water. The target armada consisted of 185 Japanese, German, and American ships, ranging from small amphibious craft to battleships and aircraft carriers.
The bomb will not start a chain reaction in the water, converting it all to gas and letting all the ships on all the oceans drop down to the bottom. It will not blow out the bottom of the sea and let all the water run down the hole. It will not destroy gravity. I am not an atomic playboy, as one of my critics labeled me, exploding these bombs to satisfy my personal whim.
Animals, plant life, even biological warfare agents were assembled to study the effects of heat, blast, and radiation. The bomb missed its intended target by nearly 800 yards. The blast sent 5 ships, including 2 destroyers, to the bottom of Bikini Lagoon. All ships within a half a mile of the blast were heavily damaged. But damage was nowhere near that created by the following underwater blast known as Shot Baker.
Bikini Baker was an underwater burst of the same device, and it produced much more damage to the armada of 70 ships. For instance, the USS Saratoga had the bottom of it essentially knocked out of it from the underwater burst, and the Saratoga sank and sets upright in the bottom of the Bikini Lagoon at the present time. I've often flown over Bikini Lagoon, and on clear days when the water is quiet, you can still see the Saratoga setting there.
The area surrounding Shot Baker had become seriously radioactive and could not be safely approached for some time. This effect was not anticipated and ultimately led to a decision by President Truman to call off a third deep underwater test, codenamed Charlie.
This is the mile-high city of Los Alamos, the atomic city. This is a modern pueblo created by the people of the United States as a research and development center for atomic weapons. Since Eniwetok is a distant and primitive area, men have to leave their stateside laboratories and homes for a period running into months. Since 1943, when Los Alamos was established, men from this mesa have left the continental limits of the United States to test the weapons they have created.
2 years after Crossroads, authority was given by President Truman to proceed with Operation Sandstone. while the purpose of Crossroads had been to test the effects of atomic weapons, Sandstone's objective was to test new weapon designs. Planning for such weapons had begun many years earlier, when the scientists on Trinity had developed other experimental designs for atomic weapons, but were unsure of their success. A joint task force was created to head out once again to the Pacific and procure the islands of Eniwetok, some 200 miles west of Bikini. Crossroads had been staged. In early November, the first construction crews arrived to strip the islands of vegetation, grade the land, and lay down tar and asphalt for roads. Within 6 months, construction crews erected temporary housing for the many scientists and military personnel required for Sandstone. Perched atop 200-foot steel towers, the 3 devices utilized on Sandstone employed new technology to double the explosive force of the bomb, using the same amount of plutonium spent over Nagasaki. This technology met Department of Defense requirements for more efficient bombs and increased the ability to stockpile nuclear weapons. Remote-controlled tanks, guided by helicopter, recovered fission samples near ground zero to measure the intense neutron and gamma radiation. Radiochemical analysis of the pulverized coral sand would yield secrets about the nuclear reaction and help in determining the efficiency of the new bomb designs. The results of Sandstone affected the design of future nuclear weapons, rendering the Mark III production components of the Fat Man bomb obsolete. The Mark IV and Mark V designs brought improved performance and lighter weight to nuclear weapons. Los Alamos National Laboratory Z Division evolved into Sandia Base, located at Albuquerque, New Mexico's Kirtland Air Force Base. Sandia's primary purpose was to engineer and manufacture deliverable nuclear weapons designed by Los Alamos. In October of 1949, Western Electric entered into a contract with the Atomic Energy Commission on a no-profit, no-fee basis to form the Sandia Corporation, which assumed control of the base from Los Alamos. Sandia brought assembly line techniques and mass production to nuclear weapons to build the nation's stockpile of tactical and strategic bombs.
Upon his return from Bikini, in public addresses, in interviews, and in published articles, Admiral Blandy made recommendations of grave import regarding the atomic bomb.
It is essential that no country gain ascendancy over the United States in the development, manufacture, and tactical use of atomic weapons.
On August 29, 1949, the Russians detonated their first atomic bomb. This event, coming 5 years earlier than anyone in the West had predicted, was largely the result of one man, Klaus Fuchs. Fuchs, a Los Alamos physicist, had passed detailed blueprints of the original Trinity design to the Russians. With the emergence of the USSR as a nuclear rival in 1949, the United States believed it had strong motivation for intensifying its program of nuclear testing.
Quite expensive and a lot of logistics involved in carrying out an operation in the Pacific. So in January 1951, the United States opened up the Nevada Proving Grounds, which we now call the Nevada Test Site. You know, this is about 60 miles north of Las Vegas. To check out the weapons for Greenhouse, Operation Ranger was conducted, in which 5 new nuclear weapon types were airdropped at that new test site.
Seconds.
With the confidence of those new weapons in hand, Operation Greenhouse proceeded in the spring of 1951. 4 shots were conducted on Greenhouse. One of the shots, shot easy, was a Department of Defense structural effects test. A 47-kiloton nuclear device on a tower was used, and it loaded many of the structures that had been developed for survivability in the nuclear weapon environment. A 4th test on Operation Greenhouse was the item test, about a 45.5 kiloton test in which tritium was burned in the very center of the nuclear explosion. And this process of putting tritium at the very center of the nuclear weapon is called boosting. And we kicked the yield up from about 20 kilotons to 45.5 kilotons, more than doubling it by that process. A very important feature in expanding the stockpile of nuclear weapons of the United States at that time. Another of the events on Greenhouse was the George event. Now, George is a large 225 kiloton weapon that was used to burn a deuterium capsule. And this is the first of our thermonuclear weapon experiments to ever be conducted.
Many people thought about it. We discussed it a lot. At the end of the war, most people wanted to stop. I did not. Because here was more knowledge. And in the coming uncertain period, with a dangerous man like Stalin around, and our incomplete knowledge, I felt that more knowledge is necessary. Among the people who knew a great deal about the hydrogen bomb, I was the only advocate of it. And that is, I think, my contribution. Not that I invented it. Others would have. And others in the Soviet Union did. But I was the one person who put knowledge and the availability of knowledge above everything else. And I must say, it appears that that appealed to Truman, and he made the right decision.
Welcome aboard the USS Estes. As you may or may not know, the Estes here is the command ship of Joint Task Force 132. We have minutes to go before the first blast, mic shot, of Operation Island. 59 minutes now to be exact. We've been here since daybreak. Left Weetalk last night during the early morning hours. Now, as you can imagine, feeling is running pretty high about now, and there's reason for it. If everything goes according to plan, we'll soon see the largest explosion ever set off on the face of the Earth. The test islands for Mike are located at the top, or the northern sector, of Eniwetok Atoll, some 25 miles from Perry and Eniwetok, the two base islands of this atoll proving grounds.
3 islands making up the test site were linked together by causeways. These connecting roads were built to make it easy to get from island to island and to act as land platforms for some of the instrumentation. Situated on the Zero Island was the cab, or building, which housed the device. The Mike device was known as a wet bomb because it used liquid hydrogen isotopes to create the thermonuclear reaction. This made the device very large, weighing some 62 tons, and impractical to use as a deliverable weapon. A plywood tube ran from the Zero Island across the causeways to a detection station on the farthest island, a distance of nearly 2 miles. This tube was filled with helium, allowing lethal radioactive rays faster travel to the detection station before the island was consumed by the fireball.
You have a grandstand seat here to one of the most momentous events in the history of science. In less than a minute, you will see the most powerful explosion ever witnessed by human eyes. The blast will come out of the horizon just about there. And this is the significance of the moment. This is the first full-scale test of a hydrogen device. If the reaction goes, we're in the thermonuclear era. For the sake of all of us, and for the sake of our country, I know that you join me in wishing this expedition well.
It is now 30 seconds to zero time. Put on goggles or turn away. Do not remove goggles or face burst until 10 seconds after the first light.
Minus 15 seconds.
In the spring of 1953, the Atomic Energy Commission and the Department of Defense conducted 11 nuclear weapon tests in Nevada under the code name Upshot Knothole. The objectives of Upshot Knothole were to test new nuclear devices, improve battlefield tactics, and to study the needs of civil defense against a Soviet attack.
The first of the events, codenamed Encore, was a 27-kiloton nuclear device airdropped and detonated at about 2,800 feet above a large blast line. The second Department of Defense burst, called Grable, was detonated at the same general area, and it was delivered by the Army's new artillery cannon. A 280-millimeter projectile was fired and detonated over about the same blast area with a yield of about 15 kilotons at an altitude of about 500 feet. Now, the smaller yield, 15 kilotons at 500 feet, produced a great deal more damage than had the larger yield Encore event, 27 kilotons at 2,800 feet. And that's because the smaller yield at the lower altitude produced a very abnormal waveform, which we call a precursor, which is very strong dynamic winds, which to drag-sensitive targets produces extensive damage. For instance, a Jeep at a given level on Encore may not have been damaged at all. But on Grable, with a precursor loading, that Jeep would be completely torn to pieces and thrown down the blast line distances like 500 feet. Well, there were many other peculiarities to those two shots, but it opened up a whole new vista of how do you use nuclear weapons in a combat situation.
Common sense tells you this is dangerous and foolish. You wouldn't risk your neck in a trick like this. Common sense tells us that being shot out of a cannon is dangerous business. Common sense tells you not to be careless at an airfield with propellers and jet engines in action. Handling dynamite. This too looks dangerous, but it's an everyday job to these men because they observe common sense safety precautions. But sometimes we forget that security violations can be dangerous business too. If classified information about this test mission fell into enemy hands, the consequences could be disastrous to all of us, individually and collectively as a nation. Security is only common sense. Don't take chances. Avoid loose talk. Safeguard classified information. Report security violations at once. Prompt action may prevent a minor incident from developing into a serious one. Avoid writing about classified material in letters home. Be sure you're secure. Don't be careless.
I hate a careless man.
Work on high-yield hydrogen bombs had progressed from Operation Ivy, culminating in the spring of 1954 with Castle Bravo, the largest device ever detonated in atmospheric testing by the United States. Bravo was a hydrogen bomb using solid thermonuclear fuel, confirming the designs of Edward Teller and Stan Ulam, and paving the way to producing aircraft deliverable hydrogen bombs and more effective weapons. significantly exceeding its expected yield by 2.5 times. Castle Bravo, with an explosive power of 15 megatons, stripped islands clean of vegetation and took the scientists by surprise. The huge explosion released large quantities of radioactive debris into the atmosphere. This resulted in the exposure and contamination of some servicemen, natives, and the crew of a Japanese fishing boat, which had gone unnoticed in the security zone around the blast. This incident pushed the dangers of fallout from nuclear weapons clearly into the public mind.
Let's face it, the threat of hydrogen bomb warfare is the greatest danger our nation has ever known. Enemy jet bombers carrying nuclear weapons can sweep over a variety of routes and drop bombs on any important target in the United States. The threat of this destruction has affected our way of life in every city, town, and village from coast to coast. These are the signs of the time. Only in practice now, a rehearsal, a training exercise. But tomorrow, this siren may mean the real thing. And if you hear it, as you drive in your auto, as you sit in your office, or work at your bench, wherever you are, what will you do? What will happen to you?
Arthur, let me tip your hat back so we can get a good view of you as I ask a very personal question. How old are you?
My next birthday, I'll be 65. Sorry to say.
That makes you the oldest and yet really the youngest from what we've observed here, inhabitant of our trench so close to ground zero. Arthur, there's a charming lady right behind you. Would you mind if we talk with her, too? I'd like to get a little feminine reaction here, too. This is Helen Lanninger from New York City. Helen, how long have you been waiting now?
Oh, for about 8 days.
9 days.
9 days, yes.
Right. Well, Grant, I guess we'd better get back up to Media Hill and see what's going on and how close to 8 hour we really are.
Well, here on Media Hill, Roy, the big story, as far as we can determine from looking out there, is the civil defense story, as well as that story of the military and the armored vehicles, the tanks and the personnel carriers. Now, Roy, once again, I want to call you in so we can take a look at our split-screen arrangements that we have here. Not only our cameras here on Media Hill, but the camera that you have down in the tent. So come in on that split screen.
In just a few seconds now, you'll see me assume this position. Matter of fact, there's our cue now. Everybody down, get down in the position. I'm going to shield my eyes against flying debris, pull my helmet down on the nape of my neck so that we don't get too many flying rocks.
All right, good luck, Roy. Now let me explain something about this screen. This screen across the bottom of the section that I am will represent 1 mile on your camera. The top part, 2 miles. We're going to switch to another camera. I'm going to move out of here.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. The shockwave will arrive in the control point area in approximately half a minute.
Almost 9 years had passed since the cancellation of a deep underwater test on Operation Crossroads. That test was finally conducted as Operation Wigwam. 500 miles off the coast of San Diego, California, a 30-kiloton nuclear device was suspended by a cable 2,000 feet below an unmanned barge. A tow line, 6 miles long, stretched from the barge. Suspended from this tow line were 3 unmanned submarines called squaws. Cameras and instruments were placed inside each sub to record the effects of a nuclear detonation. The purpose of this operation was to determine the fatal range of an enemy submarine to a deeply detonated nuclear weapon. Operation Red Wing was conducted in the Pacific, primarily to test high-yield thermonuclear devices. 7 months prior to Red Wing, the Soviet Union had demonstrated the ability to deliver thermonuclear weapons by strategic bombers, tipping the balance of power in their favor. The Cherokee event would be the first delivery by U.S. aircraft of a thermonuclear weapon. This weapon would detonate with a yield of 3.5 megatons, almost 200 times the power of the Trinity device. Cratering from high-yield detonations was taking its toll on the Pacific Test Islands. Real estate at the Pacific Proving Grounds was disappearing, and land was at a premium. Barges were increasingly employed as a cheap form of transportation to carry thermonuclear bombs out to sea for detonation. Many of these tests would document an ever-growing concern.
One special phase of the study concerned the amount of radiation that would pass through the human body. This required instrumentation in the stomach.
A small capsule was devised as a film stack with alternate bits of film and spacers. Secured with a string and paraffin coated, the capsule is swallowed. One end of the string hangs out of the mouth so that the capsule can be retrieved after exposure and the radiation measured.
Gamma radiation may do its damage in either of two major ways, or both. One, it may physically and directly destroy tissue or eventually cause the development of some kind of cancer. Those which concern us principally have life periods ranging from several years to thousands of years. They can do no harm unless they are taken into our bodies with food or drinking water, or in the air we breathe.
Let us consider the results of a powerful thermonuclear explosion at the Pacific Proving Grounds in the Marshall Islands, 11 degrees north of the equator. The huge cloud soars up, punches through the tropopause, and finally spreads and stabilizes as high as 70 or 80,000 feet, entirely within the stratosphere layer.
This brings us to the most widely discussed fission product, strontium-90. Chemically similar to the soil calcium with which it becomes mixed, the strontium-90 follows calcium through its regular cycles into our plant food and into the bones, meat, and milk of our plant-eating animals. Reaching our own bodies, the strontium-90, like calcium, tends to be concentrated in our bones, particularly those of children who are building new bones. The radiation from strontium-90 has extremely short range in the body, so it causes no genetic threat to the reproductive cells. It does pose a threat to the bone marrow and the bone itself in the form of either leukemia or bone cancer. If this should happen, it would be a tragic thing for those injured, no matter how small the number. Whether these statistically very few casualties can be justified is a personal value judgment outside the scope of this report. Each citizen must make his or her own evaluation. There are those few who loudly maintain that there is no actual threat to the free world at all, certainly none that can justify either nuclear testing or nuclear armament. The opposite viewpoint holds that the development of our nuclear power has been an absolutely necessary protection against communist hostility and nuclear threats. In this view, the fallout casualties, if any, will be seen as those of unidentified soldiers in the service of humanity. Unknown soldiers in a war which has not struck, and which our nuclear power may indeed prevent from ever striking.
In the fall of 1957, with test moratoriums looming on the horizon, 24 nuclear tests were conducted in the Nevada desert under the code name Operation Plum Bob. During Plum Bob, the Hood event would become the largest test ever conducted in the atmosphere within the continental United States. Hood, a 74-kiloton device, was suspended 1,500 feet above the desert floor on a balloon. While new weapon designs continue to be tested, the Department of Defense used the series to accelerate military training in nuclear warfare while continuing its study of the effects from nuclear explosions. The 21st test, conducted during Operation Plum Bob, was the Rainier event. This was the first fully contained underground nuclear weapon detonation conducted by the United States. The 3-kiloton device was detonated 790 feet below Rainier Mesa, vaporizing rock into a molten bubble 100 feet wide. This technology would have great importance after the Limited Test Ban Treaty, which would prohibit all but underground testing of nuclear weapons and hide future experiments from prying eyes. During Operation Hardtack, the United States detonated 35 nuclear devices, as many as had been fired in all prior Pacific tests. By now, nuclear weapon tests were perceived in large part as saber-rattling, increasing the international tensions that could lead to all-out nuclear war. Against mounting pressure, the United States government still believed that the weapons were vital and were the only counterweight to offset superior Soviet manpower. The Soviets, having just completed an elaborate series of atmospheric tests, were now likely to make a move to renounce testing, knowing full well that the U.S. was involved in a massive operation.
And operations were conducted at Inuitak and Bikini, as we had before. And a new operational site was brought in under Operation Hardtack, and that was the Johnston Island operations. During the test, one of the events of some significance is the Cactus event. This is a little 18-kiloton device that produced a crater about 137 feet across and 37 feet deep. Many years later, 1980, all of the fission debris and radioactive material on Inuitak Atoll was gathered up and dumped into the Cactus crater, and then a concrete dome was placed over the crater to keep and stabilize the radioactive material that had been contained in it.
A year before Hardtack, the Soviets launched a small satellite named Sputnik 1. Concerned by the superiority of Soviet rockets, the United States conducted its first 2 missile-borne high-altitude detonations, known as Teak and Orange. The nuclear weapons for Teak and Orange were carried aloft into space by the Redstone missile, developed by Werner von Braun. Von Braun and his crew had developed the V-2 rocket for Germany during World War II. The Redstone was considered an extension of this World War II technology and had a limited range. Utilizing liquid oxygen for fuel, the Redstone would propel its nuclear cargo into the Earth's upper atmosphere and release it for detonation. Teak, with a yield of 3.8 megatons, detonated nearly 50 miles above the surface of the Earth. The detonation created a violent magnetic disturbance in the atmosphere known as EMP, or electromagnetic pulse. This phenomena silenced radio transmissions for nearly 8 hours and damaged electrical circuits from Hawaii to New Zealand. Immediately following shots Teak and Orange in the Pacific, the United States conducted Operation Argus, 3 1-kiloton missile-borne tests in the South Atlantic. The Argus experiment sought to create and explore trap bomb radiation in the Earth's Van Allen belts. Detonating 300 miles above the Earth, the experiment sought to create a radioactive shield to impede the performance of a Soviet missile attack.
These pictures, enlarged from 16mm for your theater screen, are the first to show the hand-raising which makes history in Russia. For it marks the approval by the Supreme Soviet of Nikita Khrushchev's rise to the premiership and power that was once Stalin's. The free world awaits the obvious diplomatic thrusts, the first coming barely 4 days later. Russia announces it is suspending further nuclear tests, a statement which the U.S. brands a propaganda maneuver.
The United States is prepared, unless testing is resumed by the Soviet Union, to withhold further testing on its part of atomic and hydrogen weapons for a period of 1 year from the beginning of the negotiations.
For 2 years, an uneasy moratorium on weapon testing continued between the United States and the Soviet Union. Secretly, the Soviets began designing new weapons of mass destruction, including a 57-megaton hydrogen bomb, the largest nuclear weapon ever built. This monster bomb was a scaled-down version of a 100-megaton design and was aircraft deliverable.
Mr. Khrushchev has exploded his giant bomb in cynical disregard of the United Nations. By this act, the Soviet Union have added injury to insult. They broke the moratorium on nuclear weapons testing. They have raised atmospheric pollution to new heights. They have started a new race for more deadly weapons. They have spurned the humanitarian appeal of the United Nations and of all peace-loving peoples. They have advanced no solid justification for exploding this monstrous and unnecessary weapon. They have been wholly unmoved by the dangers of radioactive fallout to the human race. The United States delegation deeply deplores this contempt for world opinion. And we think that in the light of this somber development, other delegations may wish to express their views on this shocking and distressing news. For today, Mr. Chairman, the world has taken a great leap backward toward anarchy and disaster.
The Russians had shattered the voluntary moratorium. The United States would soon follow suit with an extensive series of weapon tests for massive retaliation. Tensions mounted as nearly 100 nuclear tests were conducted between the Nevada test site and the Pacific Ocean under the code names Nougat, Storax, and Dominic. Of primary importance were the uncertainties of offensive and defensive weapon systems in place but unproven since the beginning of the voluntary moratorium. Operations resumed at Johnston Island and Christmas Island during Operation Dominic. The United States negotiated the use of Christmas Island from the British, who had used the island to conduct their own thermonuclear tests. Multi-megaton nuclear weapons were loaded aboard B-52 strategic bomber aircraft, delivered from Hawaii, and airdropped off the south end of Christmas Island. The Department of Defense continued its advance into space by conducting 5 high-altitude tests above Johnston Island. Most of these bombs were carried aloft by the Air Force's Thor missile to continue the research of neutralizing incoming enemy warheads high above the Earth. Nuclear weapon testing had joined the space age.
This small step toward safety can be followed by others, longer and less limited, if also harder in the taking. With our courage and understanding enlarged by this achievement, let us press onward in quest of man's essential desire for peace. As President of the United States, and with the advice and consent of the Senate, I now sign the instruments of ratification of this treaty.
Tightrope was the last atmospheric test ever conducted by the United States, and it was fired from Johnston Island in a Nike Hercules air defense missile and detonated again well above Johnston Island. And that ended this whole series of atmospheric testing by the United States, when in 1963 we entered the limited test ban treaty that prohibits any atmospheric testing.
Smiling